Hey Math 1 students, so this video is going to walk you through the 9.3 task. I know we've done some of it together and some of you already sat through class and did the 9.3 task, but this is just for anybody who needs a little bit of a refresher or anybody who's absent, or if you just kind of want to hear it again to make sure you understand everything. So we're going to start by talking about the line of best fit. So we also call this the regression line. You need to be comfortable hearing it said both ways, right? So line of best fit and regression line are the same thing. And what that is it's a line that best represents the data on a scatter plot. So for example, if we look at this scatter plot over here, there's this line drawn through the middle of all of the points here. That's your line of best fit, or your regression line. Something that's really important for you to remember as we go forward is that there should be roughly the same number of data points above and below the line of best fit. The whole point of a line of best fit is it's going to give us predictions about our data. So we need it to accurately represent the data that's there. And in order to do that, it needs to go through the center of all of the data. So we need to have some points above, some points below, because that line should be right in the middle. So you'll need to be able to analyze the data in a scatter plot to determine whether a line of best fit represents the given data. So here we've got scatter plots representing the weights of dogs measured in pounds and the time it took to complete an obstacle course measured in seconds. We need to figure out which one of these shows the best model. Well, like we set up here, there should be roughly the same number of data points above and below. If we look at this first graph, this line is above all of the data points. And so what that means is if we were to use this line, it would be an over prediction of everything, right? It's above all of these points, so that would not be a good choice. This one would also not be a good choice because this line is below a lot of the data points, right? It goes through two of them and everything else is above it. So this is a really bad estimate also. Looking at choice C, that one looks pretty good. We've got some points that are above, some that are below, and some that are on the line. If we look at choice D, this one would not be a good option. This line is going straight up, but we can see that this data is has a positive association, and so our slope of our regression line should also be positive. So that is not going to be a good choice. So we get that this is going to be our best option. And the reason that it's the best is because the line goes through the middle of the data. And so really, we're talking about there's roughly the same number of data points above and below. All right, moving on to the next part. So, in addition to be able to identify the appropriate regression line, we need to be able to write the equation of the line. So there's a couple things we have to remind ourselves of. The first thing I want to remind you guys of is we've got two different ways that we can write the equation of a line, or two different forms that we can write. So we could use slope-intercept form, which is y equals mx plus b. All right, and the thing you have to remember about slope-intercept form, that m is our b, or that m is our slope. I don't know where that came from, you guys, I'm sorry. M is our slope, and b, I'm jumping ahead of myself, b is the y-intercept. And remember, we always can find our y-intercept from a graph by looking to see where the line crosses the y-axis. So it's always a point 0, and then it's our b value. So anytime you're given the y-intercept, or if you can get it from the graph, your best bet is to write your equation in slope-intercept form. The other form that we have is called point-slope form. So for point-slope form, we have y equals y1 plus m times x minus x1. And I know some of us put the y1 at the end. It doesn't matter. You can write it either way. The point here is that we need to make sure that we've got our starting point, which is that x1, y1. So this is our starting y value. This is our starting x. And then that m is our slope still. So hopefully this looks kind of familiar, and once we do these two examples, hopefully it'll really kind of stick with you and you'll kind of remember, oh yeah, we've done this a lot before. So if we take a look, this first one says write the equation of the line going through -3, 8 with a slope of 2/3. Well, we're given a point that's not the y-intercept, and we're given a slope, which means we're going to go ahead and use point-slope form. So I should probably figure out what my starting x and starting y values are so that I can make sure I use this correctly. This is my starting x value, -3, and my starting y value is 8. And then I know my slope is 2/3. So when I write this equation, I know it's going to be y equals my starting y value, which is 8, plus my slope, which is 2/3, times the quantity x minus my starting x value. Well, my starting x value is -3, so if I do minus a -3, it actually turns it into a +3. And so you can write it either that way, or some of you might go and write it this way, 2/3 x plus 3, and put that +8 at the back. It does not matter to me which way you write it, but you have to be comfortable seeing both equations, so you should probably be comfortable writing both equations as well. All right, let's talk about how to write the equation from the line, or from the graph, excuse me. So we need two things still. We still need the starting point, and we need the slope. If we look at this graph, it crosses the y-axis right here, and we don't really know exactly what that point is. So we're not going to want to use slope-intercept form. We're definitely going to want to use point-slope form instead. So we need to find some good points for us. So let's see. Here's a good point right here. This is the point 1, 1. And here's another good one. So this is the point 4, 3. So I'm going to pick the point 1, 1. So I'm going to say that's going to be my point that I'm going to use. And I need to find the slope. The thing we have to remember about finding slope from a graph is its rise over run. So I'm going to start at the point 1, 1, and I'm going to move to the point 4, 3. So I'm going to go up 2, which means +2, and I'm going to go to the right 3, which means +3. So my slope is going to be 2/3. So I'm going to use this slope and this point to write the equation of my line. So I'm going to have y equals my slope, which is 2/3, x minus my starting x value, which is 1, plus my starting y value, which is 1. And again, if you want to start with that y value first, that's totally fine. Starting y value is 1, plus my slope of 2/3, and then x minus my starting x value, which is 1. Both of these are the same equation. It doesn't matter to me which one you write. Okay, let's look at this one. Excuse me, I'm so sorry. This is exactly the same as the one above. We have our starting x, our starting y, and our slope. So when we write the equation, it's y equals -5 minus 3 times x minus 4. You could also write it with your slope coming first, so -3 times x minus 4 minus 5. Again, doesn't matter which way you write it. I want to get to this graph here. Looking at this graph, this does cross nicely on the y-axis. Since it does, that's my y-intercept, so I'm going to go right away and say that that's my b value, and my b is 4, because it crosses the y-axis at y equals 4. So now all I need is my slope, and I'll be able to use slope-intercept form to write the equation of this line. So I need another good point. There's one right here. So I'm going to go down 1, so a -1, and I'm going to go to the right 2, which means my slope, I'm going to go over here, my slope is -1/2, and the b value that we already found is b equals 4. So for this one, we're just going to use that slope-intercept form. So remember, y equals mx plus b. So the equation of this line is going to be y equals m, which is -1/2, times x plus b, so plus 4. This is the equation of the line. It's much easier to write when you actually have the y-intercept because you don't have to worry about any parentheses and where the starting y goes, where the starting x goes. So if you have the y-intercept, you should use it to write the equation of your line. All right, so those of you that are in my class right now, you guys are going to Ms. K is going to pause the video, and you guys are going to work on this quick practice. So there's 6 questions on the front where I give you a graph and ask you to write the equation. And then there are 6 questions on the back where I give you a point and a slope and ask you to write the equation. And then for those of you who finish quicker than your classmates, there are 2 challenge questions where all I did was give you 2 points and you have to write the equation of the line. So for some of you it might take a little bit of thinking to get here, that's okay. But at the bare minimum I need you to get through questions 1 through 12, and Miss K will have an answer key. She can kind of go through it with you because I just want to make sure that we're good on how to write the equations of lines. All right, so now that you've done your practice with writing equations of lines, we're going to talk a little bit more about why it's important for us to be able to write the equation of these best fit lines. The reason for that is because we're going to start interpreting really what these mean. So before, when we looked at scatter plots, we talked about them having a positive or a negative association. And then we used the variables, and we would say something along the lines of, as the number of hours that we exercise increases, the risk of cardiovascular disease decreases. So we're going to be doing the same thing right now. We're just going to be adding some numbers to it and just saying a little bit more specifically how to describe this data. So the first thing we need to talk about is slope. We know that slope is rise over run. Or another way to say it is we can say that change in y over the change in x. So remember that triangle symbol there means change. So it's the change in y over the change in x. That's what our slope really is. So once we have the slope and we're talking about it in terms of a line of best fit, we need to talk about what it means in context. So in context, this tells us how an increase in the x value, so we're going to be looking at the run, is predicted to affect the y value, or the rise. And this will make a little bit more sense once we actually do an example. So bear with me for a second. But really, it's telling us every time we increase the x value by this much, the y value is going to do blank. Okay? Then let's talk about the y-intercept. So we know that the y-intercept is the point where the line crosses the y-axis. So we know that it's when x equals 0. So in context, this tells us the predicted value of the y variable when the x variable is 0. Again, it makes a little bit more sense when we're actually in context. So let's take a look here. We've got a survey given to classmates asking them how many hours they spent playing sports in the past day. He also asked them to rate their mood on a scale from 0 to 10, with 10 being the happiest. Darren created the following scatter plot and regression line to show this relationship. So we've got along the bottom here, our x variable is the number of hours playing sports. All right, so that's our x variable. It's along the x-axis. And then along the y-axis, here's our y variable. That's the mood rating. So I'm going to go ahead and label that as my y variable. Okay, so if we look, these have a positive association. This line that's drawn through here has a positive slope. Looks like it goes through the middle of the points, which is good. So let's see what it asks us to do now. So it says, use the graph to find the slope of the regression line. Be careful with the scale. All right, so to find the slope, we know that that's going to be rise over run. So, excuse me, we need to pick some good points here. So I'm going to go right here because that's my y-intercept. That's a nice point. And then it looks like there's a good point right here. So I'm going to go up from 5 to, let's see, or actually, I'm going to pick a better point. How about we go here? That scale is weird, and so that way we don't have a fraction. So I'm going to go from 5 to 8, so that's going to go up 3. And then I'm going to go from 0 all the way over to whatever this is. So let's see, what is this? This is 2. So even though it looks like it's going farther, it's because these are going by 1/2, so we want to make sure we're careful there. So we're going from 5 to 8, which is up 3, and from 0 to 2, which is over 2. So our slope is going to be 3 over 2. So now it says interpret the slope of the regression line in the context of the problem. So really quickly, I want to remind ourselves that we said slope is the change in y over the change in x. So if we think about what these variables are, that's going to help us a little bit. So the y variable is the mood rating, which means this 3 is going to have something to do with our mood. And then the y variable is the hours playing sports. So this 2 has something to do with the hours playing sports. So let's see what we have to actually fill in here. So for this first question, we've got kind of this fill in the blank for you guys to help you through how to write these sentences. So every time the x variable increases, well, we said the x variable is the hours playing sports. So every time the number of hours playing sports increases by the run. Well, we said rise over run, so the run must be 2. We should write that. Sorry, I skipped that step. I wrote it up at the top, but I didn't write it here. So we've got rise over run. There we go. So every time the number of hours playing sports increases by 2, the y variable, so the mood rating, is predicted to increase, because this is a positive association, by whatever the rise is. So the rise is 3. So as a full sentence, we've got every time the number of hours playing sports increases by 2, the mood rating is predicted to increase by 3. So every time you add 2 hours to your workout, your mood is going to increase by 3 points. That's what this sentence says, okay? Let's try and interpret the y value now. So use the graph to find the y-intercept of the regression line. So we did that already. We found that the y-intercept was the point 0.05. So let's talk about what this means in context. Again, we've kind of got this fill in the blank for you guys to go with. So when the x variable, so the number of hours playing sports, is 0, we predict the y variable, which is the mood rating, is what value? 5. Right? So we're taking the x variable and the y variable, and then the value of the y-intercept, and plugging it into this fill in the blank. So when you don't play any sports, right, or when the hours playing sports is 0, then we predict your mood rating is 5. So you're kind of just meh if you're not playing sports. That's what this is predicting for us. Okay? Let's look at two more examples. All right, so we've got this scatter plot at the right showing the number of years since 1995 and the size of the gray wolf population in Wisconsin. The equation of the regression line is y equals 35.5x plus 104. So before we do anything, I want to take a second and I want to look at what are my variables here. So my x variable is the years since 1995. And my y variable is the gray wolf population. So if we look, these have a positive association. So in the years since 1995, the gray wolf population has increased. So we need to take this equation now, and we're going to interpret what these values are. So we said that this first value here is our slope. So we know that slope is equal to the rise over the run. Or in other words, our change in y over our change in x. So our slope that we were given is 35.5. So I'm going to actually take that and I'm going to make it 35.5 over 1, because I want to make it into a fraction, since that's what we're talking about with rise over run. So let's take a look at those variables again. We said that the rise, or the y variable, goes on top. So that's the gray wolf population. So on the top, that this 35.5, it has something to do with the gray wolf population. And then on the bottom, our run, the change in x, deals with our x variable. So the years since 1995. So now we're going to take this and we're going to figure out exactly what this means. So we can use a very similar fill in the blank to what we did on this page. So every time the x variable increases by the run, so let's go ahead and write that part first. So every time x variable increases by, what comes next? Run. So I'm looking at the page before to figure out what our sentence starter is. The y variable is predicted to either increase or decrease, we need to decide which one, by whatever the rise is. So all I did was take the exact same fill in the blank sentence that we wrote on the other page, and now we're just going to fill it in with what's going on here. So the x variable is the years since 1995. So every time the number of years since 1995 increases by the run, which is 1, the y variable, which is the gray wolf population, is predicted to increase, because this is a positive association, by the rise, which is this 35.5. So, in other words, every year after 1995, the population increases by about 35.5. That's really what we're getting at here. So it doesn't have to be this fill in the blank. The fill in the blank is kind of here to guide you through it if you're really kind of struggling. But like I said, I just put it in other words, didn't I? I said, let's see, I'm going to kind of go over here and just write another sentence. So for every year after 1995, the gray wolf population is predicted to increase by 35.5 wolves. So I said the exact same thing that I did up here in the black and the orange that I did here in the green. It's just a little bit more straightforward. So it doesn't matter to me which way you write it, whichever way kind of makes sense to you. If you need to go with the fill in the blank for now and eventually we get to here, that'd be awesome. Okay? So let's talk about interpreting the value of the 104, which represents the y-intercept. So we know that for a y-intercept, it's when x equals 0. So pretty much what we're saying is when x is 0, so the years since 1995 is 0, the gray wolf population is 104. So we could go back to our fill in the blank that we did on the other page, right? So when the x variable is 0, we predict the y variable is whatever value we get for our y-intercept. So the x variable means the years since 1995. So when the years since 1995 is 0, we predict the gray wolf population is 104. Again, there's probably an easier way to say it. I think I would probably just say, instead of when the years since 1995 is 0, I think I would just say in 1995, right? Because if it's been 0 years since 1995, it is the year 1995. So you could say something along those lines as well. I just want you to see how using those fill in the blanks from the page before can be useful. Okay, so Ms. K, I want you to pause the video and have students try number 3, and then you can go ahead and play it and show them the answers. Okay, thank you. Data was collected for 100 flights on the distance traveled during the flight and the cost of the flight. The following regression line was found where y is the cost of the flight and x is the distance traveled during the flight. So they tell us right here what our variables are. Here's the y variable, here's the x variable. So we're going to interpret the slope. Well, this to me looks like it's that y equals mx plus b, which means our slope, our m, is 0.08. So I know that slope is rise over run. And so my rise is 0.08. My run is going to be 1. And I'm going to talk about those variables again. So let's see. The y variable is the cost of the flight. And the x variable is the distance traveled. So I think the sentence that I would write for this would say, for each mile traveled, the cost of the flight is predicted to increase by $0.08 or 8 cents. All right, so if we look here, each mile traveled, that kind of ties into the 1 mile traveled, okay? And then the cost of the flight, that's our y variable, is predicted to increase by that actual value. If you want to do the fill in the blank like we did above, that's totally fine. I'm not going to write that part, but you can just copy the exact same fill in the blank we did up here and fill in the correct x variable, run, y variable, and rise. Okay? Interpret the y-intercept of the regression line in the context of the solution. Well, y-intercept means we need the b value. So the b value is 177.5 0.21. So if we think about what this y-intercept says, means the x value must be 0. Well, the x value is the distance traveled. So when the distance traveled is 0, the predicted cost of the flight is $177.21. So again, you can go ahead and look at the fill in the blank that we used in questions 1 and 2 and write it exactly that way. This gets at that exact same idea without actually doing the fill in the blanks. All right, if there is still time left in class, you guys are going to go ahead and get started on the 9.3 Ready, Set, Go. If there's not time in class, you do not have any homework. You do not need to actually work on the Ready, Set, Go. We're going to do that in class together on Friday. Okay? Thanks for watching.